Alright, that should do it. Finally, the stream is booted up and it's going. Hey everybody, what's up? Welcome back to my second stream. And today we're again continuing our Python basics. So the last thing we saw in the previous tutorial, the first one, was the different kinds of data types, comments, and printing. Right? Output, basic output. So this is basically covering up all the basics that you need to know for Python basically. And over here you can see the different kinds of data types. We have integer, float, string, and boolean. So can you even tell me the difference here, right? The difference is in integers, you do not have any decimals. In floats, you have decimals. In string, you can write characters. You can't do that in integer and float. In boolean, you can write characters, but only two types of words can be framed in booleans, which is true and false. You have to write, if you're creating a boolean with true and false in it, you do not have to keep a string in it, a double quotes in it, right? So if I do true like this, it will turn out to be a string still. But if it's like this, it will turn out to be a bool. So now starting off with our programming, right? So today we'll be first of all looking at another basic part of programming, which is lists. Now, if you want to make lists, uh, you will first of all take any variable name and put these brackets in front of it. But before we get to this, I have to clear out another part, which is operation. Now we see that we have integers, we have floats, right? But how do we add them, subtract them, divide or multiply them? That's where operators come in. Not only that, there are three different types of operators, right? So, hmm, uh, in programming, there are three different types of operators, and there are arithmetic operators, then there is relational operators, which compares things, and we have a vast or logical operators. We also have bitwise and identity operators, and uh, membership operators. Basically, we have seven different kinds of operators: arithmetic, comparison, assignment, logical, bitwise, membership, and identity. Today we'll be covering only three of them, which is very important, which is arithmetic, relational, and logical. So we have our arithmetic operators. First one being our classic arithmetic plus operator. So if I take A plus B, also there will be a typecasting, right? While I'm covering operators, I'll also be covering typecasting. Now, in integer and floats, if you add these up, or if you give a float with an integer value, right? That integer will directly convert into a float. You know why is that? That is because the float can store higher values that an integer cannot. Meanwhile, the other parts, right? We have integers. If converted to, if added with float, it will stay an integer if I'm correct. So let's take two print statements. One will print A, other will print B. Now if I'm correct, both of them should print out uh, the same thing, which is the floats. So we take A equals, of course, oh shoot, of course we will have to instance A again because you cannot instance A before B or B before A. So to avoid loopholes, we'll do that. Now if we run this, you will see we get both floats because floats store higher values. In fact, the integer we had created here automatically converts into a float. Now, here's the cool part. What if you want to add up 4 and 3 together? How will we do that? It's simple. We just use our arithmetic operator just like the way we have used it over here. Right? Uh, right. So we use our arithmetic operator which will add up both of these together. There are 4 different kinds of arithmetic operators, right? So if we start off, we have our plus, which basically adds things. Then we have, let's zoom it in so you guys can see properly. Right, we have plus, minus, subtraction. For division, now if you check your keyboard, you do not have a division symbol. So how will you divide? We use a slash. A slash can be used for division. So you can do like 10 divided by 20. For multiplication, again, you do not use x because that will probably be like a string maybe. So you can use a star, right? So these were all the arithmetic operators in Python. Now as for relational operators, there are equals to and not equals to. There's also a greater than b, or a greater than or equal to b, or a lesser than equal to b. We always use a and b here, so you can take a, b, a, b, a, b, a, and a, a. So yeah, again, we have a is equal to b, a is not equal to b. For not, we use the exclamation mark. A is greater than or equal to b. A is lesser than or equal to b. A is greater than b. A is lesser than b. Now, what is the difference between greater than or greater than equal to? So, for example, we take a equals 10, right? And b equals 9. Now, is 10 greater than 9? Yes. So, both of these, this one, this over here, and this over here, will turn out true. But if we take it to 10 instead, now is 10 equal to 10, or is 10 greater than 10? Now 10 is greater than 10, and it is also equal to 10, so this will return true. But 10 is not greater than 10. It's equal to 10 only. This will return false. Since this has equals to and this does not, that's the difference. Because if there is equals to, that means it could either be more than, or it could either be equal to as well. But in this, it only has to be more than that. So if this was 11, if a was 11 instead, then it would print true again. So that was some classics of operation, right? Then we also have our our logical operators. Now there is the most common use or and operators, which is used in logic, at least for now. That is all we need. So the AND operator is written with two AND symbols, which you can find on your keyboard right above the seventh. So you can just do Shift and 7 to get the AND. And for OR, you can find that key above your Enter key, right? And you can just use Shift and use it. So OR will basically mean uh, like A is equal to B, or A is greater than B. So if we take this, and if we take A is greater than or equal to B, it will basically mean the same thing, right? Now, and will have something different. That means both of them will have to be true to give our output as true. As for this, we have to have either one of these two statements to be true. Let's just separate them to away from each other to make it clear. Either this has to be true or either this has to be true. But if we use this, that means both of them have to be true, or else it will return false, even if one of them is false. And as for the logical OR operator, even if one of them is false, but the other is true, that's fine. But if both of them are false, if both of them are true, so fine, we'll get true. If both of them are false, then we'll get false. Right? So that's that. So we have covered operators. Now we can now move to lists. List is actually a very fundamental part of programming, right? So before I start off lists, I'll give you guys some time to revise in your mind what we have just learned here. That time I will be back in a moment. All right. Mm, hmm. So, what are lists? If anybody's clear, they can always tell me. Lists are basically. Wait a second, just give me a moment. Get through this. Right. So this is a list, right? What exactly do you mean when you say that this is a list? That means that the list is a compilation of different values which you can access forever. You can store them, change them, and remove them, and add them, of course, right? So that's what's lists. It's basically a compilation or a set of different values put together in in a single format. A list can also contain different types of values of different formats. So you can also take high and one. You can also take high and uh, hello or wow, let's say, and then one. So it can store about infinity values, which consists of anything. Uh, and that's basically a list. It can also contain decimals like floats or booleans, right? So it can basically store all ranges of data types in a single data type called a list, and that two together in harmony, right? That's what keeps a program together. Now, this is a list, but how do we access the contents of a list? If you want to access the contents of a list, you will have to, first of all, refer to your list, then use these brackets and call out the content you need. So a list always starts from 0 to whatever range there is, which let's say is n. Right, so this would be 0, this would be 1, this would be 2, this would be 3, this would be 4, 5, 6, and 7, right? So if you want to print the 0 option, you can just take list 0 and print it out, right? Currently I did not print it, that's why it's not showing. It didn't really do much, right? As you can see, it prints the high value from the list. You can always go to -1, which means the last value, right? Sorry, this is 0, right? But if you go to -1, you will again access the same value, right? You can go to -3, let's say. I think I should get 1 if I do that. right? No, we get this. So this is -1, -2, -3. So where does it store true then? Um, there's something wrong. 3, 4, 5, 6, 7, 8. No, I forgot. Oh no. Hmm, out of range. Right, there are 7 values then. Oh yeah, and do not forget to save your projects every single time you append it. Right. So, okay, that was a big mistake of me. I'm really sorry. I forgot about this value. So yeah, basically you can refer to any part of a list using the same function. Now, if we check more on lists, if you do want to print the entire list at once, right? If you don't want just a single part, if you don't want high or bow separately, if you want the entire list as it is, then you can just print it as it is, right? And you will get your output. Mm, so now you've seen how to access each and every item of a list. There's another thing. If you want to access a range of items, for example, if you don't need just high or just vowel, but you need high, vowel, and one, so you can go 0, colon, 3, right? This will get you from high to 2910. Wait, but we need to 1. So we'll get it to 0, comma 2. So we'll go through 0, 1, 2, and it will give you this much. So so as you can see, well, oh, why is there always just a moment? There's something wrong here. Mm, okay, there's an error in the bug actually. It's not in the program, in the main IDE for some reason. But it's not really necessary to bug fix it myself. So that's what we saw, high Rowan 1 printed out on the screen. Now, if I was correct, it should have printed to high Rowan 1 as soon as we got to 2, because it goes 0, 1, and then 2. So if we do 1, 3, it should only print Rowan 1, right? Yeah, exactly. So there is some value between wow and 1 which I cannot find. So there's probably a bug here, right? Anyway, so if you want to add something to the list, how would you do that? Now, Python, as I said, is an object-oriented programming language. That means it depends all on objects. So that means we have to get a function from list because this is technically an object. In fact, every data type that you see will be an object. And there are different sets of code that you can use, right? Different, what would be the word for it? Different functions that you can access and use it to like make your program better or create a functionality in your program that you need, right? So if you want to add something to your list, you will have to use there are two methods to add something. Actually, there are three methods to add something to your list, right? The first method, as everybody knows, is the append, right? Now, what append does is it will add it to the end of the list, which means we will have hi, we will have thou, and at the end of the list, it will add what you need. Let's say, um, temp, right? This will be added to the end of the list, and it will print it. So first it gets added, then it gets printed. And again, there's an error. Oh, of course, I forgot. So if I put this away from this, and then I print this one as it is. Right. So now we get hi, val, and temp. Right? It gets added to the end of the list. Then we have the insert method. What is the difference between append and insert? Now append, as I said, adds to the end of the list. Why was I referring on adding to the end of the list again and again and again? It's because in insert, you can choose on which spot do you want it to come in. Currently at the spot 1, we have val, and at spot 0, we have hi. So instead of putting this to spot 3, spot 2, you can put this to spot 1, which is at the place of val. Where does val go? At spot 2. At spot 2, right? So if we do that, we should get high temp val. As I said, then uh, lastly we have extend. Now the difference between all of these three I will explain later, but what extend does is, let's say we have a list 2. Now you cannot put list as it is because it refers to a data type. You cannot create it like this. Unless of course you're using like this, right? So let's create a list 2, right? And let's say it has the values mm, apple and banana. Right now, how does this help? If you want to add list 2 inside of list 1, right? If you want to take this and put it in this as it is, like just copy the entire info and put it in this. How will you do that? You will do list 1 dot extend, and then you put list 2. Of course, you can also use list 1 dot extend separately, right? Like this, and put in just one value, like sub, right? It will work. Uh, but instead of doing that, we always prefer to use append or insert. This is used for higher, like a collective number of values usually, right? As you can see, we will have high val and then apple banana, and then we have high val and apple banana, right? So that was it. Now, if you want to change items, you can just uh, refer to list 1, right? List 1, and then I want to change val to temp, right? So I just do 1 equals. So this means that this part of list 1 will be changed and will be equals to what? So we can say it will be equal to temp. And then if we print this one, we have hi and then we have temp instead of saying hi and val. Of course, if you don't want it like this and you want to remove val and put values of list 2, you can always do that, and you might get it like this in a nested list. The nested list is very complicated, so we'll get to that later on in another tutorial. Currently, we have to stick to the basics. So that was how to change values, and just the way you can access the values, you just have to access the value, and then you put your new value after an equal to sign. Oh, and uh, uh, there should be assignment. The only assignment operator for Python is the equal to sign. The equal to sign is an assignment operator. It assigns a value to a data, right? This is a data, This is a value, and this is the data's data type. The type of data that the data has is data type, right? Very, very basic knowledge. I'm pretty sure you might know that. It's basically common sense. All right, now moving on. We have the remove. We have to remove our uh, things that we have right in the list. Now we have a few things. So the first way we can use, right? Let me put. Firstly, let's append this to this, right? So list one dot extend list two. Right now we'll have all of this together because we need a long list first. So we can do list one dot remove. Now remove is one way that you can use to remove your data, and you can directly specify it. For example, if I want to remove Apple from this, right? Now let's first print our list one before removing it. So we can do print list one, all right? And we run it. You can see we have high val apple and banana, but once we've removed it, we will not have apple anymore because we've removed apple. Now you cannot do the now another way to do this is using the pop method, right? The pop will remove things based on index, right? So for example, if I use pop and I do remove one, we have high val apple banana and I remove one. So one over here will be 0, 1, 2, 3, right? Now if we remove one, it will remove val. And as you can see, there is no val in here. Pretty neat, isn't it? So that's what pop does. Now, uh, there's one last method to do it, which is quite nice. So, uh, I will remove this and put it like this, since we need to remove Apple again, right? You can use the del command. The del will remove this index. Again, it can remove specified index, but another function of del is that it can remove the list entirely, right? And then if we print list one, so we will have three prints, which will have the original, the one without Apple, and the entirely removed list. Line 15. Of course, yeah. Uh, Now this you see here, we have a name error. This is why. Why is this? Because in line 15, which means 15th line of the code, you will not find list 1. In fact, it will tell you to use list 2. Do you know why is that? Because we have deleted the list as it is. There is no more list 1 for you to see, right? So if we do this again, we have high, wow, apple, banana, high, wow, and banana. So it does the same thing, except it can remove your entire list at once. As you can see back here, you can print the list because it's no longer even there. Brutal? I know. Now, another way to delete every value of the list without getting any errors is to do list1 dot clear. Now, dot clear will only remove the values and not delete the variable as it is. Now if we print list one, it won't give us an error. This is because it will give you a blank list instead of deleting the variable, right? Now, one thing that comes in many programming questions, and which is to loop through lists. It is very, very important that you need to remember. But before that, many people ask me, like many people that I've taught have asked me that why are there so many different methods? Why is there remove and pop separately? Now, there is a reason for it. In programming, questions mostly, right? When you get problems or challenges, uh, the remove function will only remove a specified item. What if you don't know what the specified item is? Like, for example, if you have a list, right? If you have, just a second, this is a list with apple, banana, kiwi, and avocado, right? Actually, let's go with cherry instead. I like cherries. Sure, right? Now we have a list like this, and we know that there will be a list which has four values or which has a certain number of values. What if you don't even know the amount of values there are? And if you do, let's say there are this many values, four values, right? Going from 0 to 3. But you do not know what the values are. For example, if this was hidden, if you could not see it, right? It would be something like this. Can you see it now? No, you can't. How do you solve it? Of course, you can see the variable by printing because you still need to know what the values are. Plus, it's kind of hard to do it again and again and again. So, what you can do is you can use pop and refer to just, let's say if you want to remove banana. Remove will make it look like you need to remove banana or you need to remove this index, right? And if you know that there is a list like this and you can see its index that, oh, banana is on index 1 and you need to remove index 1 as according to the question, then you can just use list 1 dot remove banana. But if you do not know what's on index 1, that's when you use pop. So you just do list 1 dot pop 1 or the first index, right? So that's the difference. That's the use of putting them in different terms. And the reason why they did not put it in the same term is because of complications. It would make things more complicated for people to learn. And it might seem easy at the first look, but no, it's not. It won't be. Putting them in different values, putting them in different functions was a genius idea. Now, if you have a list with apple, banana, kiwi, and cherry, and you want to print the entire list except you want each of their values to print separately. If you don't want it to go like apple, banana, kiwi, cherry in brackets with commas and colons. No, you don't want that. You want apple only, banana only, kiwi only, and cherry only, and all of them being in different lines, right? Like this. That's how you do it. So you take your list one, right? Then you just loop through your list. What does it mean to loop through your list? It means that you go on every single iteration one by one. What's an iteration? It is every single one of these indexes that you see will be an iteration when you're going through the list. So you can say for x in this one. So this would be x, 0. Right? 0 index would be x. Then 1 index would be x, 2, x, 3, and it goes on. Now you need to print every index separately from list 1. So it would be the same as printing it like this, like list 1 and then x, right? Doing that and printing it directly would be the same thing, right? But the only problem is, we do not. It's not like they are indexes. If they were 1 2 3 4, that would have been making more sense. But since they're not indexes, they are the values one by one. So apple is X, banana is X, kiwi is X, right? If they're the values one by one going through, that's why you can't get that. You have to go for X because that's kind of like the iteration. The iteration would be the value, each value separately. And as you can see, as I said, you want each value separately, apple, banana, kiwi, cherry, on different lines without having these brackets and all that. So that was how to loop through a list. But if you do want, uh, let's say, you do not want to print like, you don't want to do it like this. Something is wrong and you want to, or like, there's a complication and you need it differently, like you need it like this. How will you do that? It's simple. All you need to do is you take your list one and put range and length. That means it'll check the length and it'll go for the range of it, which means it will instead make the length, right? It will put the length of list one in a different variable, and since over here the length is 3, right? So it will print to the range of 3, right? Range 3 would mean it would go through 1, 0, 1, 2, 3, like that. And the length of this one is 3, since we can see 0, 1, 2, 3, right? So it goes through that and then it goes to the range and it gets every single number one by one and puts it in X without uh, changing the list as it is, right? Without even looking at the list. And then it prints the values of the list separately. Again, doing the same thing. Right? Same thing, no difference. Except just a bit different, a bit changed. Right? No big no big thing. Now we can use it do it using while loops, for loops, or whatever. Right? In this example we have used for in loops, which is again ahead of the current things that we need to show, but it's a very important part, so I had to show it. I will teach more about list comprehension and you know I'll teach you more about looping in the next few tutorials, I guess. Currently, we have to get through this. Maybe we'll be next checking out dictionaries before we get to if statements and loops. So, now we will see list comprehension. And, but before that, I just want you to take a look again and remember what I've shown you here. I'll be logging back in a minute. Okay, I will be teaching list comprehension later on since it's too advanced. Currently, let's get to sorting lists, right? Now, there is like two ways to sort lists. I mean, there is a single way to sort lists, but it sorts in different categories. Let's say we have another list called list two, right? And instead of being apple, banana, kiwi, cherry, we can put it something like mm, 1, 2, 7, 4, right? And again, we have four values in this as well, just for example. So now, what does sort do? So we can use list one dot sort and list two dot sort. Okay? So let's print both the lists before and after sorting. right? So we will print. Now, what does sort do? Sort will basically arrange all the values of the list in two types of orders. First one, if you have every single one of them, if you have strings in your list, right? They will arrange the strings alphabetically, like A, B, C, and then comes D, E, F, G, H, I, J, and then we come to K. Right, so go A, B, C, and K, and then it will have numerically, which means from 1 to infinity, basically, or minus infinity to infinity, right? So whatever the smallest value will come first. So 1, 2, 4, 7. It'll go like that, right? So that's how it sorts. Just give me a minute. I'll be back in a moment. Hello? Huh? Yeah, I did. Okay. Okay, bye. Alright, so for this room, come back. So numerically basically means from smaller digits to larger digits. So now we will print it before we have sorted it, and then after we have sorted it, right? So let's see how it turns out. Right, as you can see, it is apple, banana, kiwi, cherry, right? Alphabetically. And once we sorted it, it'll come out perfectly. As I told you, A, B, C, and then comes K, a lot later, and then 1, 2, 4, and then comes 7, right? And it prints exactly in that order alphabetically. So that's just sorting. That's it. That's all about sorting there is. There's another thing that you can do in sorting. For example, you can put reverse equals true. This is basically it will sort everything in descending order. Okay. True should be capitalized. T should be capitalized in T. Alright, don't forget that. If you if you put it to reverse, it'll basically print the same thing except in descending order. Right. Now, what you also can do is you can sort only. Right. So sort is has one thing that it is case insensitive. So even if you have capitals, let's say if K, or let's say if C was capital, right? It would ignore that and print the same thing, like just like this, right? But if we do s T equals str dot lower, right? Now what does str dot lower do? It basically changes your strings, all like the strings value. For example, if we have a string that is with cherry, let's say, right? This is cherry. Now if we use str.lower, it will remove all capital letters from cherry and turn it to small letters. So over here we're saying that the key that we need is string lower, right? I'm sorry, there was no supposed to be a second bracket, right? So that's that. Uh, Right, so case-sensitive sorting would give a unexpected result which we don't need. Case-insensitive sorting would basically give us the same result that we need. For example, if it was case-sensitive, then C would have came here at the first. No, it would have. Right. So let me just run this once more to show you how it would have came out if it was not case-insensitive. As you can see, C comes at the first part, which we do not need because C is supposed to be placed after B, right? Because it goes A, B, C, not C, A, B. So if you want to turn it case insensitive, you will have to do key equals string dot lower. I'll be back in a moment, and I'll see you in a while. See ya. All right. खाना मैं खा रहा हूँ ना